So let theta be any angle in standard position and let A comma B denote the coordinates of any point. Mute you guys, I hear too many dogs barking. Take no offense. All right, coordinates of any point except the origin 0, 0 on the terminal side of theta. Okay, so if R, this is a very wordy definition from the book, but I'm going to draw you a simple explanation in a second. R is equal to A squared plus B squared. So if R equals this, denotes the distance from 0, 0 to AB. So I didn't define formally sine, cosine, tangent last time, so I'm going to do it here a little bit. Then these 6 trig functions of theta are defined as these ratios. Okay, so here we go. So basically, if you don't have a unit circle, you will have sine theta defined as B over R. Cosine theta will be A over R. Tangent theta will be B over A. Cosecant, of course, are the reciprocal functions, which we've talked about. That'll be R over B. Secant theta will be R over A. Cotangent theta will be A over B. Okay, so visually, all this is trying to say is you have some theta, some line, some terminal side going all the way out to some point. This is theta right here, all the way out here. A comma B. So in the unit circle, sine was the y value, right? We've been talking about that for a while. Cosine was the x value. It's just that this terminal side is no longer unit 1, so the radius can vary depending on the circle. So if the circle is bigger, you just change the bottom part. But the way you do it will be the same. The way you define them, everything will be the same. It's just we're using something other than unit 1, which won't come up very often. The question will tell you if it is or is not a unit circle, okay? So just remember, change R. Okay, and the next definition before we start any examples is coterminal. coterminal angles. So basically that means two angles in standard position are said to be coterminal if they have the same terminal side. So basically what I mean is if you go around the circle multiple times, you end up at the same place as a different angle, then those are considered to be coterminal. Like for example,
can you slide it up a little bit?
Yeah.
Thank you.
Thanks. Let's say, I don't know, right here is 45 degrees, right? Now, let's suppose I went all the way around and then stopped right there. This new theta would be coterminal to 45. So this would be what? 360 plus 45. So that would be 405. So you see how they're the same, right? And if you're wondering where this came from, remember, one full circle is 360, right? So 360 plus that 45 would be coterminal to each other. So 45 degrees and 405 are coterminal. That's what the definition is saying. Okay? So basically, you can add 360 or 2 pi, depending if you're thinking in radians or not, to any angle and you'll end up in the same place. Okay? You can keep doing that forever, and you can find an infinite number of coterminal angles technically, right? You can keep adding 360 and landing there over and over again. I'm not saying you should do that, but okay. Does the idea of coterminal make sense? Before I move on to something else. Okay. Let me know if there's something weird or strange. All right, another definition. Reference angle. So let theta denote an angle that lies in a quadrant. The acute angle formed by the terminal side of theta and the x-axis is called the reference angle. I don't know, space it right there. Okay, let me give you some examples. Okay, here. Okay, let's say they have an angle over here, which we will call some theta. The reference angle would be, see if I can use a different color here. Would be this reference angle. So the distance from the x-axis to wherever the terminal site is, as the definition is saying, the acute angle formed by the terminal side of theta and the x-axis is called the reference. So given some theta, how far am I till the x? The acute angle. That'll be your reference. So when they ask you for a reference, that's what they want. Let's do another one. And then we'll do examples in a second. Let's say your angle is way down here. So your theta is right here, right, all the way around. The reference would be this distance. How far am I from the x-axis? So that would be reference. I can't write reference in there, but you see what I'm saying, right? Okay.
So in that case, it wouldn't be to the other x-axis of quadrant 1?
Oh, that's to be the one that's acute.
Okay.
The acute angle. So this is the key right here.
Gotcha.
Okay. Do maybe one or two more. Okay, let's say the angle goes all the way around up until here. Right, so that's my theta, right? So the reference would be the acute angle to the x-axis. Oops, my hand smeared everything. Okay. All right. Let's say it went the other way. Let's say it went negative degrees, right? All the way to that piece. Reference would still be the acute side. Okay. Do you have any questions on how to find a reference angle? Okay. Let's try doing some actual examples then. We use a coterminal angle to find the exact value. And this is going to be done without a calculator.
Can you slide it up a little bit?
Mm-hmm. So let's say a sine of 110 degrees, or sorry, 1,110. 1110. So since that is greater than 360, that's going to be bigger than a circle, right? So we got to decide how many circles is that. 360 again is 720, so that's already 2 circles. So what you could do to find the exact value, right, It just keeps subtracting 360 from there. Let me grab that.
I got 750.
Let's see. You subtracted already?
30
Yeah.
degrees.
Cool.
Oh,
Let's see.
I saw like another one. Oh, okay.
360 minus 360 minus 360. Looks like there's 3 circles in there. Eventually I run out of circles. And I'm at 30 degrees. So really, the coterminal angle is 30 degrees. So you'll just find sine of 30 with your unit circle. This should be what value?
1/2.
Yeah, that's 1/2. That makes sense. Is anyone confused by that example so far? So imagine visually, right? So we can connect this to our first drawing. Not this stuff, but the page before. So we know it's going to be, I know it's going to be around here, 30 degrees. So what happens is it goes around one time, twice. So one circle, 2 circles, and the 3rd circle. And finally end up here. Hopefully I didn't draw too many circles. So 1110 is multiple circles, 3 of them, plus 30 degrees. I know that looks like crap, but do you see what I'm saying? That's the idea. So just keep, whenever you have a big angle, just remove the redundancy, I suppose. Because if you spin around in circles and end up in the same place, well, you don't really have to do that, do you? Just remove it. Okay. And I'm assuming you guys know that 180 is a complete turnaround and 360 is just a 100 complete spin around, right? 180 would be from here to here, right? 360 is all the way back where you started. Okay. So your first couple of homework questions will look something like that. They'll just ask you, find the exact value. Meaning they don't want you to do like, they don't want you to just plug in sine of 1110. They want you to do this step. Okay. They will also do it with radians. Just remember that if you have a number that's bigger than 2 pi, that's like the same as 360. So you would subtract 2 pi over and over again. But if you don't want to deal, if you do not want to deal with radians, you could convert the question to degrees first, and then just do this. Just subtract 360 over and over again. Let me see. Let me show you. Use a coterminal angle to find the exact value. All right. I'll just make my own up. 1 second. Yeah, we'll do that. Let's say we had sine of 9 pi over 2. And they want the exact answer. So you could convert this to degrees, or you can start checking and subtracting 2 pi. Okay, so one way to do it would be to take the 9 pi over 2 and subtract 2 pi. And then see if you're below 2 pi. So subtracting that would require fraction stuff, right? So that will be 9 pi over 2 minus 4 pi over 2, which will be 8 pi, no, 5 pi. 5 pi over 2. Okay, that's still too big, so you have to do it again. So you'd subtract 5 pi over 2 minus another 2 pi, which will give you 5 pi over 2 minus another 4 pi, which will finally get you to pi over 2. So this guy is equal to sine of pi over 2, which will be 1. So see how this is the same thing as up here. It's just that they used degrees on this question, and over here we did not. If you do not want to deal with it again, convert the 9 pi halves to degrees if you feel that is easier. It's up to you. Doesn't matter. Okay. Are there any questions on example 1 or 2? I'm going to move on to reference angle. All right. All right, here we go. Example 3, I believe. Find the reference angle of 125 degrees. So which quadrant do we land in if I were to draw 125 degrees?
Two.
Yeah, it's gonna be the second, right? So 90's up here. So that would be what? 125, somewhere over here. Okay. So what we want to know is how far am I from here, right? That's what the reference is, we said. So, like I said before, from going from here to all the way this way is 180 degrees. So if I subtract 125 from there, I'll know how far this is. So all you have to do is subtract from 180. Let's see, that is
55.
okay. Yes. Any question about that? So it helps to figure out where exactly am I landing, because if you don't know where you are, then you don't know what the acute angle is, right? So that's the tricky part. Like on this next one, I can't tell by looking at it because it's in radians. Find the reference angle for 31 pi over 12. I'm like, okay, I don't know where the heck that lands, but we could either convert it or subtract 2 pi. So we know 2 pi is 360, right? So 2 pi is about 6.3-ish. 31 pi over 12 is technically bigger than that. So I do know that this went beyond a full circle. So you can subtract by 2 pi and then see where you're at, okay? So let's go ahead and do it that way, and then I'll do it with degrees too, just so you can see. So I know for a fact now that I checked that this is bigger than 360 degrees, so I need to subtract by 360, right? In other words, 2 pi. So then get a common denominator, so I'd have to multiply by 6 over, oops, no, actually 12. So 12 over 12. That would get me 31 pi over 12 minus 24 pi over 12. What is 31 minus 24?
7.
Yeah, so 7 pi over 12. Okay. Still not super clear where we're at, right? So that's okay. Now let's convert it and do the same thing with degrees. So you can decide what's easier for you. So I'm going to convert this using the stuff we learned from the first couple of sections, right? We multiply by 180 over pi. That will cancel the pi's and leave me with 31 times 180 over 12. I don't know if that's going to be pretty or not, but it's all good. So this will be 465 degrees. So subtract 360 because that's too big, right? So that would be 105. So now that this should be clear as to which quadrant we're in, I hope. Because we know 90 degrees is up top, right? Right here. This is 0, that's 90, that's 180. So we have to be somewhere around here. So this angle is 105 degrees. What is the reference angle? So 180 degrees minus 105. What is that going to be? I think it's 75, right? Oops, wrong color. Okay. Does it make more sense converting to degrees? If you feel like it does, then right at the beginning, when you see this question, just convert it. Don't even worry about this. Okay? That would be okay. You're going to get the same answer. But if you skip this second line here, you would just start there, convert it to 465, and right away you know it's bigger than 360, so subtract 1. And that's less than, so just find out where that's at. I know that 9 degrees is up here, right? zeros here, 180s here, right? 270. These are all the common angles. And if you don't know that, then look at your circle and figure out where the heck is 105. Okay? Either way, as long as you can figure it out, then you can do the subtraction. Do you have any questions on 3 or 4? All right. Theorem. Reference angles. So if theta, oh, sorry. Yeah, that's fine. If theta is an angle that lies in a quadrant, and if alpha is its reference angle, then following is true. Sine theta is equal to plus or minus sine of alpha. Cosine theta is equal to plus or minus cosine of alpha. Tangent theta is equal to plus or minus tangent of alpha. Now the reciprocal functions. Cosecant theta, same deal. My alphas look like Jesus fish. Sorry about that. Secant, secant alpha. Cotangent, same thing. That will be same thing. Okay. So basically what you can do is just switch to, like if you're trying to find sine of some angle, alpha or theta, you can just switch to using sine of the reference angle, and it'll still be equal. The plus or minus, though, that comes in from where the plus or minus sign depends on the quadrant in which theta lies. Okay. Don't forget that first quadrant, everything is positive, right? Second quadrant, x is negative. I'm gonna make this a coordinate. Y is positive. Third quadrant, they're both negative. Fourth quadrant, x is positive and y is negative. So you will use the plus or minus depending what you're looking for and where you're at. Okay. So if theta is over here and they ask for cosine, then it's going to be negative. And let's do some examples because I know it's always easier to see once you start trying to do it. Example sometime. So for example, use the reference angle to find the exact value of a trig function. Okay. Sine of 135. So what is the coterminal angle for 135? Sorry, reference angle.
45.
Yeah, it's going to be 45. So this is equal to sine of 45. Now, sine this is going to be quadrant 2, right? So is that positive for y? So this stays positive. So that will be root 2 over 2. Part B. Cosine 600 degrees. That's clearly greater than 360. 720 would be 2 circles, so this is only 1. So that's the same as saying what? Cosine, what's the 600 minus 360?
240.
So then 240 is in which quadrant? So this is, from here to here, this is the coterminal, by the way. We haven't done the reference yet. Okay. So let's look at let me open up the circle real quick. So I'm going to keep drawing that. Okay. So, stupid thing. So 240, it's right here. So the acute angle to there is going to be what? So 240, this time since 240 is bigger, I'll subtract. I mean, it doesn't really matter as long as you make it positive. You could do 180 minus this, but you got to make it positive. So that would be
60.
Yeah, I think so. Reference, oops, make a note here. Reference angle is equal to the absolute value of 180 minus 240, which is negative 60, but absolute value must be positive. Okay. So the coterminal would be negative, because we're negative down there, negative cosine of 60. Cosine of 60 is going to be what?
Square root 3 over 2, or 1/2. Square root 1/2.
Going to be 1/2. So minus, built in already, 1/2. Is there any questions about part A or B? Okay.
Can you move it up a little bit, please?
So I had to subtract it from 180 and I got 160. Why did you do that? Because it was coterminal?
Because it was, since it was greater than 360, that means we went around the circle more than once, or at least once. So I want to know where exactly did I land on, right? Because you can spin around over and over again. Let's look at our circle real quick. So like this is 0, right? The starting point. So if I go all the way around, that's 360. But they gave me 600, so I'm like, okay, well, so that means I went beyond one full circle and I landed at 240. But the only way to tell where exactly did I land at was to subtract from by 360, getting rid of that excess. Because I don't need to know how many times I spinned around. Because I could go around this thing 20 times and then land somewhere, and then I'd have to remove all those extra circles because they're just in the way.
Okay.
So that's what I did here. Went back to the question. So since it was more than one circle, I took away one, left me at 240, and then we decided, okay, what's the coterminal? Well, subtract by from 180, choose a positive, and add the correct sign.
Okay, I got it.
All right. Where's my picture? Here it is. Okay. So negative 60 means I went this direction. So this is negative 60. But if you couldn't see where exactly I'm landing, what you can do to figure out what is the coterminal. So whenever you have a negative, just add 360 to it, and that should fix it. So now I'll know that if going negative is this way, but going positive would be 300 degrees. So I'd end up there anyway.
Okay.
And then you can just choose whatever you need. You would choose negative, right? This is the same as sine of 300, which is negative root 3 over 2.
Thank you.
Mm-hmm. So yeah, there will be some negative questions in there where you got to figure out coterminal or reference. You just got to figure out where exactly are you. So if it's really large, you subtract. If it's negative, you add 360. Subtract 360. That's a good question. Making it more formal. Because how we said, right? If we subtract 360, then we're pretty much done. So the first couple of examples in your homework in 7.5 will ask you questions about these properties, and then it'll jump to problems like this. It'll say, you know what is cosine of 390, right? And we know that's greater than 360, so that can be rewritten as cosine. This step is not necessary, it's in between one. I just want you to see that the properties of the unit circle are going to apply to the trig functions. So this is the same as cosine 30, which will be square root 3 over 2. That makes sense. You see how we've been already talking about this stuff, right? All right, let's move on to another question. So the first like 7 or so questions would be stuff like this. Let's do a negative one. Negative 45. Well, we said we could add 360. This would be the same as 315 degrees. Actually, I'm sorry, hold on a second. I skipped an idea. Yeah, scratch that. That's a different way to do this. Before we start that question, I need to mention even and odd properties. So the first thing you deal with is the periodic, which is this, and then you go to even and odd. We'll come back to that question later. So do you guys remember even and odd functions from college algebra? Like what it meant to be even? If you don't, it's okay. Let me show you visually. Okay. All right, so let's say, I don't know, we had some function equal to x squared, right? Now, if you were to plug in -1 in there, let's see if it lets me, I don't think it will. No, not this one. Yeah, there it is. So, f is x squared. If I plug in a negative, it becomes positive, right? Because you square it. You guys remember doing that?
Yes.
Now, the fact that plugging in 1 or -1 gives you the same output means it is even. That's a definition. So basically, let me give you the definition in general. So parabolas are even because of the square. But more appropriate, more precise would be to say a function is even if f of negative x is the same as f of x. Meaning if I plug in a negative or the positive, I get the same thing, like I did with a -1. A function is considered to be odd is odd if when I plug in a negative, it's as if it just flipped all the signs of the original. So the negative's in front. So for example, let's do some little examples here. F of x equal to x squared, as we said, plus, I don't know. No, yeah, that's fine. Leave it that way. F of -2 is 4. F of 2 is 4. So that shows me that it is even. Let's say we have a, I don't know, x cubed plus x. If I were to plug in a -1, I would get -1 cubed plus a -1, which is -1 minus 1, right? If I were to plug in a 1, I would get 1 cubed plus 1, which is equal to 2. You see how if it is odd, you get the same thing except it just needs a minus, right? So if I put a minus on it, then that would satisfy the odd definition, okay? So this is what we talked about way back in college algebra, whenever you did that. So for sine and cosine, the new stuff. Where's that thing? There it is. For sine and cosine, sine is considered to be negative because when you plug in a negative angle, it's as if you just plug in a positive angle and then swap the sign of the output. So these will be, that will be odd. Cosine will be even. If you plug in a negative angle, it's as if you didn't plug in a negative at all. Tangent, negative angle is odd, so negative tangent theta. Cosecant will be odd because it's the same as sine, right? Just a reciprocal. So negative cosecant of theta. Secant, negative angle will be the even as well because it's based off cosine. Secant theta. Tangent, sorry, cotangent. Cotangent of negative theta is equal to negative cotangent theta. Okay. One moment, please. Sorry, I feel like close all this. Right. Anyway, so you see how these are odd, right? Odd functions, even, odd. I'll give you an example right now. So for example, this would be example 2. These are little side examples. Okay, so even and odd properties. Cosine of negative 30 degrees is the same as cosine of 30 because it absorbs the negative because it is even. So all you have to do is find cosine of 30. So that would be root 3 over 2. Does that make sense? Example 3, let's do cotangent of negative pi over 2. So cotangent is odd, so the same thing, this would be equal to cotangent, negative cotangent of the positive pi over 2. What is cotangent of pi over 2? Should be cosine over, yeah, 0. So depending what type of function it is, you can pull out the minus sign or leave it in there, whatever. Does anyone have questions about even or odd? I don't know if that's
No.
weird or not.